Our next talk is by Moritz Mock, Barbara Russo, and Russo Melegati from the University of Bolzano, and they are going to talk about enhancing test-driven development with generative AI. Thank you.
Thank you. Hello, everybody. Good afternoon. Yeah, my name is Russo Melegati, and I'm here presenting this work that we... that we have been working in our research group here in the University of Bolzano. And so we are talking about generative AI or large language models. So we are basically using the same, recently using these terms a bit exchangeably. They are a bit different, but what they have in common, what they are really about. They are about these models that they have been trained, and they, on these large data sets, several amounts of data, and basically what they are trained to do is to try to identify the next, or to predict the next token given an input. So for every token in the output, they consider both the input and what is already gave as output. So with this simple mechanism, they can do what we see, and it's really impressive. I think everybody has this experience of working with or trying to play with these models, and we can see that they are quite impressive. So they can do really interesting things. So a good example is GPT-4o, for example, or all the family of GPT or Gemini. All of them work almost similarly. Of course, some small changes in the architecture and so on, or the training data and things like that. So, as I was saying, and you have experienced, they are really impressive, but you probably have felt some limitations. They have several limitations, or some of limitations. We are not talking about all of them today, but I think two of them are really clear and important for our use in software engineering that we are seeing later. It's about the lack of explainability and hallucinations. So the first thing is about explainability. So what's explainability? Explainability is about is the possibility that the human users can understand and comprehend and why the tool or why the model is giving that output. And based on that, you increase your trust on the output. Because if something is a black box, as generally these models are, you cannot really trust if if they are working properly or not. And this is particularly difficult for these models because they are really big, and it's really hard to understand why they give a specific answer for a particular question that you had. For example, GPT-3. I gave GPT-3 here example because GPT-4 is more closed source, unfortunately. So they don't, until GPT-2 and 3, they were giving some details about these models, and OpenAI is not giving anymore. So, but we know that GPT-3 had 175 billion parameters. So it's different numbers and that make this model. So it's impossible for a human person to understand how these numbers affect the output, and we can explain this output. So it's basically intrinsic for these models to be or to have really difficult explainability. And another problem is that is the fact of hallucinations. So hallucinations is this property that they have that sometimes they give some authoritative answers. So the users are tended to believe or influenced to believe that the things that the model is saying is true, but not generally is not, or it cannot be. It's not true. It's false. A good example for software engineering is what these groups of researchers found out. They realized that ChatGPT was they were giving some request for ChatGPT to create some code in Node.js, and we're using JavaScript. They used some imports that were packages that did not exist. So there is the possibility that attackers, since these repositories are open and anyone can contribute to these repositories, a malicious attacker, a malicious actor could create malicious packages that would be imported for example, for a person that uses this code generated by AI. So the point is that given the intrinsic way that these models work, there are some risks when using it. And the thing is that that's why we are here. AI has this possibility of being used for software development. This is because programming language is a different type, is a form of language. So we are communicating with the computer, but basically it's a language. So the way that generative AI has been trained, it can also be used for software development. So I think everyone here had this experience of using for software development. So this brings us the question: how can we tackle the issues that we mentioned before? So explainability, this lack of explainability, and the hallucinations. So one idea that we had and we explored through 1 year, more or less, here in the university, was to rely on tests, and specifically on test-driven development. Why tests? Because with the tests, when you write a test, you can use it to check the created code. So you can write the code that, generally it's a simpler code to write the test code than writing the production code, and it can be used to guarantee or to check the created code. And the idea, and the good part of TDD, it has this mentality of writing always the test to the code that will be created. So you guarantee that there's a higher coverage. So you can rely on the generated code more. So just a refresher. So what's TDD about? TDD is this approach of writing code or programming that you, before writing the final or the production code, you write a failing test. So, and then you write just enough code that makes that test pass. So this guarantees that every line of production code is somehow tested in a way from your test code. Then you can also use that after to refactor the code and try to improve it. So our problem statement, what we investigated, can generative AI be used to automate TDD? To do that, we proposed 2 interaction patterns, and we created dedicated prompts to make these patterns work, and then we test them using ChatGPT's API, so GPT at the time 3.5, GPT 3.5, and we consider different agents for each talk. For interaction. So what was the first interaction pattern that we proposed? Was the one that the developer was going to write the test and ask the ChatGPT, the GPT-3 to create the test, the production code. Because then we realized we focus on the idea that it's easier, so the developer would be faster to write the test and not the real implemented code. Another idea, let's say, what would be the dream would be like a complete AI-based TDD. That here, in this other pattern, not only the test code, not only the production code, but also the test code is created by AI using some prompts that the developer just tell what he or she wants to test. So we performed an experiment with 16 people, comparing the non-automated TDD, let's say the standard TDD with people, and with collaborative pattern. And we also run one time the fully automated, because this is just one case, right? We performed this experiment in Python. We used Google Colab, so people could do it online or from their own. We guarantee the same environment for everybody like this. And they had 40 minutes to complete a specific task that we defined. And we used, at the time, GPT 3.5. Here is a long table of the results. I don't expect you to read all of them. I'll just give you some points so you can take a look on what happened. So for here on the last line of the table, you can see the results that we got for when we try to do the fully automated. As you can see, it was really faster. It's faster than the time that both the collaborative and the traditional TDD, human-based TDD, they took to perform this. But if you see, there were not so many tests created. So there's a tendency from the AI to already solve the complete problem, and without making the steps that guarantee that the test is correct and so on. So this is something that you have to take into consideration. Then we had this, let's say, the comparison between the collaborative and let's say the conventional way. You can see that with the collaborative, there were more assertions, so more tests were created than in average than the one the person is doing. So by using the AI, the person was a bit forced or had to create more tests, and this by leaving the AI to create the test, they had more time the AI to create the implementation code. They had more time to create tests, and they were more focused on this. So it was really good, and this is also the difference that we observe. That is when a person is. However, is that when the person is doing by itself, generally it does more iterations. So again, we can see that AI has this tendency of writing more things at once rather than doing the small steps. So the conclusions of our experiments that you can use generative AI, and it has the advantage of creating code that's already tested, or there's an automatic testing. The problem is sometimes if you use using AI, sometimes is the creativity or the quality, the diversity of the code. It's a bit lower, and there is we also observe that AI needs supervision, and a junior developer might need some heads up to take care, or the junior developer might have higher risk to be misled by this AI generated solution. That's all I have to tell you. Thank you, and I'm open for questions.
Thank you. We have plenty of time for questions. Do you have any questions from the audience? Please.
We have a test with ChatGPT 3.5, but there are a lot of other LLM around.
Yeah.
Do you think that in the future maybe you can repeat the test so we can see if there are advanced on the topic, because GPT-4 or Anthropic
Claude
there are more advanced than 3.5 ChatGPT.
Yes, probably. We are running already with 4.0 at least, new tests, but to a certain extent, these limitations that these models have, they all share, right? I was reading already, as long as we don't change the architecture that we are using for these models, I don't expect that there will be a significant change. I mean, of course, they will improve. Maybe they will get better results, but there is always this need of some supervision of the output with the current architecture.
Thank you. Any other questions? I have one myself. Do you have some tips or suggestions on how you would write tests, or how you do maybe add comments or something that lead to better outcomes?
So if you have the experience with AI, with these models, you see that the longer the output, the higher is the chance that it will be out of control and create or hallucinate, or you guarantee that the thing is right. So my suggestion is that you keep let's say the good practice of trying to write smaller pieces, smaller methods, smaller classes, so you can make smaller tests, and then you can guarantee that the model will there is a higher chance that the model will create something really useful for you rather than when you try to create something bigger, you might think that you have save time, but actually probably will be the opposite, that you have to fix many things. So try to keep them small. That would be my suggestion.